All right, it says factor the trinomial, but wait! Look at this. In this position right here is a 12. We're not used to seeing that. This is a new thing. So the equation takes the form ax squared plus bx plus c, and this is an instance where the a is something other than 1. So let's just start to experiment and see what happens here. I know my first term has to be 12y squared, so I could get that by doing 3y. And over here, I could get that by doing 4y, and now I have 12y squared. This term over here has to be 36, so I know I can get that by doing plus 6 and plus 6. And therefore, I've got 36 on the last, and I've got 12y squared on the first term. This middle term is negative 48y, so let's see, that's 24y, and then that's 18y, but that's not going to give us 48y. It looks like this should be a negative value. So let's try it as a negative value. If we did 3y minus 6 and then 4y minus 6, I'd still end up with positive 36 for the last term. I still end up with 12y squared for that first term. Now it's just a matter of the middle term. So let's see, that'll be negative 24y, and this will be negative 18y. Nah, that's only negative 42y. Let's try this again. No, this isn't it either. This isn't it either. You know, we've tried a couple different things. You notice I tried 6 and 2 to get 12, but I also tried 12 and 1 to get 12, and I also tried 3 and 4 to get 12, and none of it worked because I was trying 6 and 6 to get 36, and 9 and 4 to get 36, I guess negative 9 and negative 4. And I tried that again right here, that combination. There are other ways to get 36. There are many ways to get 12. This is a difficult problem. As Einstein said, we have to stay with it a little bit longer. But I want to show you a little shortcut to see if maybe we can put you out of your misery here. So these things all have something in common. If you notice, 12 is going to go into all of them. 12 is the greatest number. We could also say that 2 goes into all of them, 4, 6. But I want to pick, or even 3, I want to pick on 12 because that's the greatest one. So you can see I've isolated 12 from this expression here. And now we're left with something that says y squared minus 4y plus 3. These are much tinier numbers to deal with. They have a lot less factors as opposed to 12, which has many factors. I think there are 7 numbers that go into 12, including itself. And no, 6 numbers, including itself. And 36 also has many factors. So this kind of limits your potential for guesses. So if we look at this now, I need to get 3 for an answer, and I need a negative value right here when I add them. So if I do y minus 3 and y minus 1, that will actually get me this part right here in parentheses. And I'll show you that right here, y squared. And once you combine those like terms, you get y squared minus 4y plus 3. And always keep in mind that this 12 has been there the whole time, so you don't want to leave that behind. But 12 is still multiplying all these things together. That's what you're left with. So really, when we talk about factoring this, this is what we're looking for right here. Let's try one more. You might want to pause the video right now and see if you can put together what we just did. I know that my good friend Selena, she's not very frustrated by this at all. She actually, her favorite book is the Book of Algebra, surprisingly. I think, anyway. I got to verify that with her. But I think that's her favorite book, and it should be yours too. It's a worthy companion for you as you try to solve these and simplify these polynomials. And you can see I've taken out a 9 from this. And even after taking out a 9, there's still a number that goes into these, so that number would be 2. So what I'm going to do is I'm going to take out a 2 now in addition to this 9 that I've already taken out. So in essence, what I've done is I'm taking out 9 times 2, which hopefully we recognize as 18, because 18 is actually the biggest number that goes into all three of those. So this would be what I've got, and now I just need to look at this part in parentheses. It looks like you're getting negative 5 for the last term. So one of the terms has to be positive and one of the terms has to be negative. And you've got more negative in this middle term, so that would mean that your negative term is going to have more absolute value than your positive term. And again, I'm not going to lose sight of the 18. I'm still multiplying this by 18. I mean, that's what the beginning problem has us do. But I've got this part right here simplified to r minus 5 times r plus 1. And I'm just going to show you why this equals r squared minus 4r minus 5 by distributing the r and then distributing the negative 5. So that first term, that last term, it's hopefully pretty obvious at this point that the r times r is going to equal r squared. And the negative 5 times 1 is going to equal this negative 5. It's the middle term that's always the most difficult, but negative 5 times r is negative 5r. r times 1 is 1r, and it's positive, so we combine those like terms, you get negative 4r. And the rest of that will still be here. And if you notice, that's what I had right here in this step. And if you multiply all that by 18, you would get back to this original expression.